So I'm now going to do another few examples of using substitution. So let's see an example. And in this example, substitution is not just helpful, making the problem easier. It's actually the only way that we can possibly do the problem. So let's find the integral of 3u squared sine of u cubed. Now there's one little, I don't want to call it a trick, but a caveat for this problem. The person who asked the problem used the letter U, which means that they already gave the letter U a special meaning, which means that when I work the problem, I'm going to have to use a different letter to substitute, and I'll just use W. So instead of U equaling something, I'm going to let W equal something, and the candidate that I substitute for should always be a complicated function inside of another function. And in this case, I'm seeing a u cubed here. So let's see. If I have a u cubed, then I can take the derivative of both sides. The left becomes dw over du, but we'll rewrite the du on the right. And we'll take the derivative of u cubed to get 3u squared. And again, we were very fortunate because there is my 3u squared dw in the original problem. So what does that do for me? Well, I can take that, and now I'll rewrite the original problem, but I'll replace the 3u squared dw. All of that will be replaced with the dw. And then I'll rewrite the sine of, and again, I've got a u cubed, but I've replaced u cubed with w. Now, what does that do for me? Well, what is the integral of sine? That would be negative cosine. So I can write that. That's going to get me negative cosine of w plus c. But again, w is this thing that I made up, so I'm going to have to substitute back. And looking at my problem, my w was u cubed plus c. And that's my final answer. You can always check your substitution problems to see if you did that right. So let's go ahead and do that. It's an optional thing, but I'll give it a try. So if I'm going to check it, I'll just take the derivative of negative cosine u cubed plus c. Of course, constant has a zero derivative when it's by itself. Constant multiples come down. Constants by themselves, though, go to zero. To take this derivative, I'll bring down that negative. Cosine will become negative sine. But since I had a complicated inside, I've got to use the chain rule. That's sine of u cubed and multiplied by the derivative of u cubed, which is 3u squared. Of course, those two negatives cancel. That's plus 3u squared sine of u cubed. And that checks out. That's exactly the same as what I was asked to integrate, 3u squared sine u cubed. It's exactly the same. So good, I got the correct answer. You can always check your integral problems if you have some time to do so to make sure you got the correct answer by just taking the derivative. Okay, let's do another example. All right, this example, find the integral of x divided by x squared plus 1 dx. So, again, I look at the problem, and when doing a substitution problem, I need to identify what the most complicated part of the problem is. And looking at this problem, I'm seeing an x squared plus 1 in a denominator. So that's what I'm going to hope to substitute. I will let u, since it's not being used for anything else, u is what I'll call it, be the x squared plus 1 in my denominator. And then the derivative would be du equals 2x plus 0 dx. And so I've got the x squared plus 1. I'm going to replace that with a u. However, notice that I don't have 2x dx in the original problem. I only have an x dx up here, x dx. So that's okay though. If it's just a constant difference, a constant multiple difference, then that's no problem at all. I'll just throw a 1/2 on the left, and 1/2 times 2 cancels on the right. So I get that 1/2 du is x dx, and that x dx will then be replaced with my 1/2 du. So let me rewrite this as x dx becomes 1/2 du, and then I still have another fraction, 1 over, and then x squared plus 1 was replaced with a u. That should just be a u on the bottom. X squared plus 1 was completely replaced with u. All right, and that's a great thing to see because I can bring down the constant multiple 1/2. And what's the integral of 1 over u? Well, that's the natural log. In fact, that's how we define the natural log function. It'll be the natural log of absolute value u plus c. And finally, to finish the problem, I just need to note that, well, hey, what is my u? My u is x squared plus 1. So I'll replace that. That's 1/2 natural log. The u gets replaced with x squared plus 1. And it doesn't hurt to keep the absolute values, but notice that x squared plus 1 has to be positive, so there's no reason to keep it around. And then add a plus c. And there we have it. That is my solution. Let me do one more of this sort of problem. Example. Find the integral of 4 hyperbolic sine natural log of t divided by t dt with respect to t. That's what that dt at the end means, is that t is my variable. So again, substitution problems are a bit of an art. You have to take a look at them and identify the most complicated function that's inside of another function. And you also need to look for its derivative somewhere, because that's what's going to be involved. And so looking at this particular problem, I note that the natural log of t is inside of the hyperbolic sine, but I've also got a 1 over t, or just a t in a denominator. And that's the derivative of natural log, and that's what you want to identify. So let me note this. I've got, if I let u equal natural log of t, then my du would be 1 over t dt. So here's my 1 over t, which is just the t in the denominator times the dt. So putting all this together, what do I get? So the 4 stays, the sine hyperbolic stays, but the natural log of t has been replaced with u, and the 1 over t, the t in the denominator times dt, was replaced with my du. All right, so where do I go from here? I'm going to get the 4 constant multiple comes down. The integral of hyperbolic sine is hyperbolic cosine. There's no negatives involved in hyperbolic cosine or sine integrals or derivatives. The u comes down because that's just the variable now because it showed up here in the du, plus c. And then finally, I'll replace the u with my substitution. That's going to be a natural log of t plus c. And there's my answer. And of course, if you want to check, you could just take the derivative and you would end up getting 4 sine hyperbolic natural log of t all divided by t, which should be the derivative of this solution.